Hey everyone, welcome back to DTech Automation. In this video, we'll explore the heart of every pressure transmitter, the pressure sensing technology. We'll understand two main types, piezoresistive and capacitive ceramic sensors, how they work, what principle they're based on, and where each one is used. So let's begin our journey into the core of pressure measurement. What is a pressure sensor? A pressure sensor is the component that directly senses the process pressure and converts it into an electrical signal. This is the very first stage of a pressure transmitter, where mechanical energy becomes electrical. Today we will talk about two types of pressure sensing technology. Piezoresistive pressure sensor technology, which means the electrical resistance of a material changes when mechanical stress is applied to it. When pressure is applied, is the pressure sensor. A thin silicon diaphragm deforms. On this diaphragm, 4 resistors are implanted in a Wheatstone bridge pattern. As the diaphragm bends, these resistors stretch or compress, changing their resistance. Electrical principle on which this work is known as Wheatstone bridge. The Wheatstone bridge converts resistance change into a voltage signal, where the output is calculated by supply voltage multiplied by delta R by R by 4. X is supply voltage, typically 5 volt DC inside sensor. Delta R is change in resistance due to pressure. The output is a very small voltage, usually in millivolts, proportional to applied pressure. This signal is then amplified and processed by the transmitter's electronics. The function is simple. When pressure is applied by the media, the diaphragm of the sensor gets deflected, which results into change in resistors. Then Wheatstone bridge gets unbalances, resulting in providing an milli-volt output. Then the amplifier boosts signal. This signals is captured by microprocessor, which then converts it into 4 to 20 milliampere digital output. This is how a piezoresistive cell converts mechanical pressure into electrical signal. Sensors having piezoresistive technology are mainly used in clean media or gases, such as pharmaceutical industries, food processing industries, and many more, with a high accuracy of 0.1% FSO. Due to its excellent sensitivity, it can be used in a process where the pressure is very low with high accuracy. Industries like Endress+Hauser and Baumer use this technology in their instruments. Now the second technology is capacitive ceramic pressure sensor technology. Capacitive ceramic sensors work on the principle of capacitance variation. A capacitor's capacitance depends on the distance between its two plates. When one plate moves due to pressure, capacitance changes proportionally, which is denoted as C equals epsilon A over D, where C equals capacitance, epsilon equals permittivity of dielectric, and A equals area of plate. D equals distance between plates. This works on simple method, where sensor made of high purity ceramic, L2O3. The ceramic diaphragm acts as one capacitor plate. The base electrode is the second plate. Between them is a small vacuum or dielectric layer. When pressure acts on the diaphragm, it slightly bends toward the fixed electrode. This deformation changes the capacitance, which the electronic circuit converts into a voltage signal. Signal is passed by below method when the pressure is applied, the diaphragm get deflected, which results into change in capacitance. AC excitation signal measures delta C. Then the converter converts delta C into voltage, and then the amplifier linearizes and provides an analog or digital output. This output voltage is then processed, just like in piezoresistive sensors, amplified linearized, and converted into a 4 to 20 milliamp output or digital signal. Key comparison between the two technologies. P. Sensor material. In a quote, piezoresistive technology, silicon diaphragm is used, whereas in capacitive ceramic technology, aluminium oxide is used as a diaphragm. Measured signal, P. Change in resistance is capture and output is generated in piezoresistive technology, whereas change in capacitance give the output in capacitive technology. P. Outputs. Piezoresistive technology gives a millivolts output, and capacitive ceramic technology gives output in picofarads. Because and many features are mentioned here. Two main brand which uses this technology is Endress+Hauser, and another one is Baumer. Each technology has its own advantages. Piezoresistive sensors are ideal for low-pressure ranges and high-accuracy applications. Capacitive ceramic sensors are perfect for harsh process media, high overpressure, and long-term stability. Both are widely used in process industries, from water and wastewater plants to oil and gas, pharma, and food processing. So now you know the science behind the pressure sensors inside transmitters. Whether it's the silicon piezoresistive sensor of Endress+Hauser or the ceramic capacitive sensor from Baumer, both technologies convert pressure into electrical signals with high accuracy and reliability. If you liked this deep dive, make sure to like, share, and subscribe to DTech Automation, and stay tuned for more videos on instrumentation and process control.